And I'm sure people will trickle in, but let me go right into sharing screen and remind us where we are here. Let me clean this up. So we've been talking about mechanism of anything, and not sure this qualifies as AI, but it's certainly AB, artificial behaviors, doing things like opening sliding doors, turning on and off lights, changing their colors, doing that sort of thing. So in this little setup here, I've created the wall and our door in between them. And the door I've placed inside a container. And this container has a sphere collider on it that's set to be is trigger. This is the thing that's gonna trigger my transition from closed to open. And I then drill down into the container. I start with the container and open an animation window, and I drill down into the door. The door is the child of this thing, the A door. And I make two animations, one for the door closed, which is in the closed position. And I've deleted the second set of keyframes, so there's only a single keyframe here. And I've also made an animation for the door open, where it's at the position that's gonna be an open door. When I make these animations, it makes an animator that's attached to my door container. It actually makes a controller with the same name as the object on which you're fiddling with this. I've added the door open to the controller. The door closed I've set to be the default, and I've made transitions between the door closed and door open that trigger on the open parameter. It opens if it's true, and it closes if it's false. And the other thing you might notice here is I've made the transition fairly short and quick for it to open, because I want the door to get out of the way of my moving character. But I've let the door close over a longer period of time because my character presumably is clear of the door then. And so I can let the door close more slowly as after the character passes through it. And so I've got my little character running back and forth here. Whoops, I think I got lost on the other side. I have my little character who runs through the door and comes back through the door. And so the door opens more quickly and it closes a little bit slower. And importantly, both of these transitions have the has exit time turned off. If you're going to use a condition, you want the exit time turned off. If you want it to finish its animation, then there shouldn't be a condition and the exit time is clicked. Important little details that make things work better. If you have has exit time checked while you have a conditional, it'll still work, but it will complete the animation before it exits, even if the condition has been set. So the little script that we put on the door container caches the animator in Awake. It gets component animator, and then it just watches a trigger enter. If the collider that's entered the trigger is tagged the player, then it sets the Boolean to be open. If it on trigger exit, the collider is the player, it sets the open to be false. So very, very simple scripting here, controlling the behavior of my sliding door. Now, I might want to put some lights into the scene to turn them on and off, and or to change their colors. So I'll create some lights, a door light. I might make a child object that is a self-illuminated sphere, so it actually looks like a light, or I can combine the two together with a light component added to an emissive object. And I want to be sure that the colors match between my lights. So let me look at this scene here with Ethan. And I have a door light, and the door light has a sphere collider. That's probably not necessary. It has a color. The material, it has a light. So this red glow material is red with emission turned on. I'm using a legacy self-illuminated shader here. You can use a standard shader as well. And I have made animations for this where I'm accessing the light color. So this is the color of the light that is being emitted by this light. And for the red light, it's all red. And for the green light, it's all green. And again, only a single keyframe. The animator has a red light and a green light, playing each of the appropriate animations with transitions that are going to again, transition between the red and green light when the open case is true. And again, I've turned exit time off, and I have the same transition back from green to red, again, with the exit off and the condition open is false. So a little modification then of my script. And I didn't show you here, but the animation for this door light also accesses the mesh renderer color. So I'm doing the same thing with the mesh renderer color that I'm doing with the light, so that this object is going to change its emissive color as well as change the color of the light that it's emitting. Those are two separate things. So to this activate door and lights script, I'm going to add an array of animators that I'll call lights. Each of the lights has an animator on it. Where's the animator? It has an animator on it, the door light animator. Both these lights, I have a light on either side of the door. Both of these have animators on them. And so I have this array of lights, and in my door container, my door opener script now has this slot for the two light animators, door light 1 and door light 2, that will open. Let me show you a little trick here. If this is 0 and there are no lights entered into it, I can grab this and just drag it onto the light slot, and it opens, it adds one and the slot. If I drag this other one onto the light, it adds the second one. So this is an easy way to set the slots. You don't have to put in the size and then drop them in. You can just drop individually in. Another little trick here, I'll set it back to 0 again, and I'm going to lock this inspector. So now when I go to other things here, this inspector stays open. Now I can select both of these and drop both of these into the light, and it adds both of them. So if you had a whole list of things that you wanted to add to the opener script, you could do this easily by grabbing them all, dropping them on the lights slot, and it would then populate it without you having to do anything. And if I'll unlock that and it'll go back to looking at different things. So that's a little trick there with the inspector, the little tiny lock button here. So I have this array of lights. Awake is the same. It's going to cache the animator on the character. But now in my on-trigger enter, in addition to testing for the player and setting the door to be open, I also have a little for each loop that goes through each of the lights and sets that its parameters to be open. So this is going to go through all of the array of lights that I have up here in my exposed variable. And similarly close them with a for each. So not a lot of fiddling, one little for loop added to it, for each loop added to it, and we're ready to go here with my little character who can now run through the door, and the light changes to green as he goes through it, and then when he exits it turns back to red again, and I can run back and forth through the door here and have the lights change color, both the light that's emitted by the light and the color of the the emission in the light's material. So pretty cool. And as I've shown here, with more than one light, you can load them into the inspector slots, and they're all triggered by that for each loop. So we can also have lights that turn on when a player is nearby. These are kind of motion sensor lights. If they detect a player, or if you wanted to, an enemy AI, the light would turn on and reveal this enemy is under the light. So again, we can have a light, an object with animations, two animations. In this case, when the light is on, I'm using a flickering animation. Let's see, where's this one? This one here. Don't save. So here I have some active lights. I have a flickering directional light. I have a flickering point light and a flickering spotlight. And the I have an turn off the light, which is one of these single keyframe things where the light intensity is just set to 0. And for the activate light, I have a flickering script. If you can see the curves here, the light flickers, its intensity goes up and down with time during the animation. And so my character underneath one of these flickering lights, the light kind of flickers as it's on. As I step out of the trigger, and again, this is just a box trigger that is set to turn on and off the parameter in my little animator, the lights will flicker on and off. Let me get the right light. I'm under the flickering directional, I believe. So the light is active. It's doing the flickering. If I step outside that trigger, the light goes off. I've got a little spotlight over here that comes on. It's using the same flickering animation. And I think I have another little light over here right by the door that is also flickering. One thing that you might find kind of interesting about this is that with this directional light, it's a flickering directional light, and I have actually put a cookie on it. And it's odd to think of a cookie affecting the directional light, but it does. It affects the directional light, and it makes the appearance of the cookie, which is this sort of grid-like pattern. And this contrasts with the grid-like pattern that's produced by the spotlight, which is more focused into the area of the spot. And of course, I have these 4 wall lights here. I have these 4 wall lights, 2 on each side of the door. And when I go through the door opens, those lights turn nicely to green. And as I come out the other side, they turn back to red again. So a lot of really cool stuff that you can do with these animations. And I will also remind you of the feature that we have with animations, that we can add a state machine behavior that will do something when the state begins, do something each frame while we're in that state, and then do something else when we leave that state. So we could have particle effects that are instantiated when the character hits the door. A big cloud of smoke goes off, or sparks come out. Or we can do something really fancy with the renderer of the door. We can turn off its collider, so the door could, instead of sliding, it could gradually turn transparent, and its collider would be turned off so that we could go into the door. Any number of different things. These animations can access every component of our object, the light, the transform, the collider, all of these different, including the script, the animator light script that's on the object. So very powerful tool that lets us do tons and tons of stuff here. So back to this light that we're turning on and off. And again, it's almost exactly the same as what we did with the door. We cache the animator, and then in the on trigger enter and on trigger exit, we check to see if the object colliding with it is the player, in which case we just set the Boolean activate to be true or false, and everything works exactly the way we want it to. So I'll stop sharing there and entertain any questions. Remind you to type your name in chat. So this is all very cool, and a very powerful tool that lets you make interactable objects all over your world that give your player powers, activate. You could use this to activate an upgrade on your player. If there's some little object that you want to find, your player has a script on it that gives it some superpower, like an additional shield or extra points or whatever. This could be the thing that enables that component on your player that gives them the extra powers, invisibility, who knows. All of these things are possibilities with this mechanism anything. And the trick is that you make a single keyframe, you have transitions among the different objects based on the Boolean that you set with your trigger, the is trigger collider that surrounds your little object. Very cool. So let me go back to sharing here, and I'm done with this one. So let me go to the next effect here. And I'll quit this. I'll quit this. And I'll open Waypoints. Waypoints is another form of AI. Sometimes we have AIs that we want to patrol. We want them to go around a circuit. And we want them to go from waypoint 1 to waypoint 2 to waypoint 3, and to kind of cycle around through a little circuit. that the character is going to cycle around through here. Sorry, let me get this cleaned up a little bit. So the idea here is that we have a series of waypoints. These are objects in the world that we can place wherever we want to. And we're going to number them from 0 to however many there are. And we want it to go to point 0 and then to point 1 and then to point 2. And when it gets to point n minus 1, where there are n points, then we want it to cycle back to point 0 again, so that it'll close this waypoint loop that we've generated. With different scripting, of course, you could make this a ping pong effect where it went to n minus 1 and then it turned around and went back through the numbers in a negative way, but that's more scripting. So to do this, missing prefab. What's the missing prefab? I don't know what the missing prefab is here. That's annoying. It looks like it's a light. Okay, looks like it was a light missing. Okay, so for this, I'm going to make a very simple AI motor, a script that controls our character, and it has one goal. It's looking for a target. It's trying to get to a target. And it has two exposed tuning variables. One, its speed, how fast it can move forward, and two, its rotation speed, how fast it can turn. And I'm going to use a character controller to control this thing, which I'm going to, of course, cache in the awake function so that I don't have to get component character controller every time I need to use it. So in the update function here, I'm going to test if I have a target. I'm going to use a look rotation to form an orientation, a rotation that will look in the direction of my target, which I form with a relative position vector that is just the vector between the target and the transform myself. A kind of important test here is to make sure that the relative position is not a 0 vector, because the look rotation does not like 0 vectors. If a 0 vector doesn't have any sense of rotation. So I have this little test here just to make sure that the relative position vector is not the 0 vector. So I formed that look rotation that's going to look in the direction of my target. And I'm going to use a quaternion slurp to gradually move my objects, my AI's rotation towards this look rotation that points at my character. And here's that tuning parameter rotation speed. This is one of these progressive ones where you take the initial rotation, rotate it a little bit towards rotation, and then store it back into the transform rotation so that it's a little bit of movement towards the rotation each time. But this happens every frame, so ultimately it will get there. And this is going to orient my AI. This is going to turn it towards the character, towards the target, and then I'm just going to move forward with this, the exposed speed parameter times that transform forward unit vector, and doing this in a time delta time so that it moves at a uniform speed. So this is the waypoint navigation that that my little character is going to use to move around. Now, I want to set up the waypoints here. And so I have these waypoints, And with the waypoints, it's kind of convenient to put them in an empty game object. So I've put all my waypoints here in this empty game object. This makes it easier to keep track of the waypoints. And we'll see when we get to Unity's waypoint system that this is the way to do it. And I've numbered these in a kind of sequential way so that I can keep track of where they, what they are and where they are. So I've got my little waypoint circuit here, and I'm going to tell you how this yellow line is made in just a second. So this is the simple waypoint script. I have this array of waypoints. I have a proximity, and this is how close I have to get to a waypoint in order to satisfy the condition that I have arrived at it. And this we often have to tune, because if we want it to be too close, sometimes our character can't actually turn quick enough or move slow enough that it can get to it. And so it'll orbit around the waypoint without ever reaching it, because it just can't turn fast enough to get there. I have various privates for the target ID, the current target, the motor. This is what is on the AI that we're going to be setting the target of. This has an exposed variable target that we will set from the waypoint script. And just a number to keep track of how many waypoints I've got. So in start, I'm going to cache a copy of the cube's motor, the AI script that we're going to be setting the target on. I'm going to set the initial target to be number 0, and I'll set the current target to be waypoint 0. And then I go on to the update function. Here, first of all, I form a vector between my current target position. That's the current target that I've set here. It's waypoint 0. And the transform position, and I've found the magnitude of that to make it into a float distance. And if the distance is greater than that proximity parameter or variable, the thing that says how close I have to get, if I'm greater than that distance, then I just reassign my motor's target to be the current target. So I'm kind of updating the target. I probably wouldn't have to have that in here, but it's good to have it. If, on the other hand, I'm close enough, I can now go on to the next target. So I do a target ID ++, which increments my target ID. I test to see if it's greater than or equal to the number of waypoints that I have, this waypoint length that I had here. And if it happens to be greater than or equal to number, that means I've come to the end of my loop, and I need to go back around to 0 again. And so regardless of what happens here, I set current target to be target ID again, and this will then end up updating the motor's target every time through here. Now, the little yellow line is a trick that is created with the onDrawGizmos function. And this is in my simple waypoint script. And in the onDrawGizmos, I'm going to set the color of the gizmo to be yellow. And then I'm going to draw lines between each of the waypoints. So first between 0 and n-1. So that's between the first one and the last one. And then a little loop that goes through and draws line segments between each other pair of waypoints. Now, here's where this conditional comes in, or this directive comes in, the execute in edit mode. This means that this script is active even when we're in the editor, even when the gameplay is not going on. And that is what's drawing this little waypoint circuit, this little yellow line that goes from point to point. And you can see here, if I take one of these, if I pick one of these and move it around, the line updates in the inspector while the game is not running. And that's because this script has this execute in edit mode directive placed before the class heading. So that's a cool trick, something that we would like to do, because having this yellow line makes it easier to lay out your waypoint. So let's see if this thing works. I can turn the gizmos on in the game view, and I can now actually see my little player going around here. I believe I've turned off. No, this is not one where there's a target. So this is targeting each of these different waypoints, and our proximity has to be adjusted to be large enough so that when we make that sharp turn at the end of this, we don't end up orbiting around the waypoint, unable to get close enough to it because we can't turn fast enough. And these are all fiddle things that we have to fiddle with to make sure things work and we have our waypoint system. So let me stop sharing quickly here and entertain any questions about a simple waypoint system, because I'm going to show you a more complex and much more powerful waypoint system next. Any questions?
I have a quick question. So the player's targeting the waypoint, but it's not going directly towards the waypoint. Is that correct?
Right, because we're using a slurp to adjust its rotation. So it turns gradually. It doesn't turn instantly to go to it, although you could set it to do that. I believe if you made that rotation rate really, really high, it would turn really quickly and just go directly in straight lines between the points. But I have a parameter that controls how rapidly it can turn. And so it, with the slurp that gradually changes my rotation from the direction I'm going to the direction I want to go, it makes it move in a more realistic fashion. Okay?
That makes sense. Thank you.
Cool. Okay, so that on gizmos is, of course, an interesting tool, and the execute and edit is also an interesting tool. Now, in standard assets, Unity provides us with a waypoint tool, a waypoint circuit script, and a waypoint progress tracker script. And these two work together. They're just here in the utility folder down here at the bottom, which of course is underneath my thing. Waypoint circuit and waypoint progress tracker. That's because the RU screen sharing covers that up for me so that I can't see it. So with these tools, there are a couple of tricks. So first of all, we put the waypoint progress tracker on the AI object. So over here in this new scene, where this is the standard assets, don't save. So here's my little character cube, and the little character cube has the waypoint progress tracker script on it, just dragged from the utilities and added. We have to make a child object for my AI. I don't know that it actually has to be a child, but it's convenient to make it a child. It can be an empty game object, or it can be a mesh object that you can see what you're following. It could actually be a little AI itself, a little puppy dog that runs ahead of your character. I'm not sure how you do that, but that's a possibility. And we want to assign that waypoint target object, which is just a child of my character. It's a little ball. I want to assign that to the target of the waypoint progress script. So I've assigned this object. I've assigned this object to be the target of the waypoint progress tracker. Now, the waypoint progress tracker is going to move that object, and your character is just going to target it with its own little cube motor. And so it's going to follow that object around the waypoint circuit that we have to set up. So with the waypoints, again, we're going to have an empty game object that contains as children all of the different waypoints, just like the simple one. In fact, it's exactly the same as the simple one, except I've added to the container here a waypoint circuit script. And the waypoint circuit script is the thing that's going to define this waypoint. It's going to make this little yellow line. Clearly, it has an execute execute in editor directive in it, and it has this set of waypoints that are in here. Now, I've already loaded this, but if you just take an empty game object and put a bunch of objects in it that are numbered sequentially, and this is kind of important, we'll label all our waypoints with 001, 000, 001, 002 in the order that you want the waypoint circuit to traverse them. And the reason for this is that it alphabetizes them and puts them in numerical order. So I put all these gizmos in here. Actually, I think I can show this with the simple case. If I take the waypoint and I add a component waypoint progress tracker, and I add, no, I didn't want the tracker, I want the waypoint circuit. I want the waypoint circuit. So it doesn't have any objects, but my objects are all children here, numbered sequentially. Now all I need to do is press this assign using all child objects buttons, and it populates it. So this populates this thing, and now you can see that this waypoint circuit now has its own yellow line around it. And so it's set this thing up. I'm going to remove that component, go back to normal. So I've already done that with this one. I've already pressed the assign using all child objects. And incidentally, if you go and add a waypoint 010 and waypoint 011, and you want to add them to the circuit, you just press that button again. There are some other things here for removing waypoints and for reordering them. You can move them up and you can move them down with these little gizmo keys. And then if you press the auto rename, I think it actually renames all the waypoints in here, although I've never tried that. There's a little setting here for whether you want a smooth route or a straight line route. This is a cubic spline that goes through all the different points. And the editor visualization is how many segments that line has. When you start to get a really long route, it can start to have kind of straight line segments, and you can increase that editor visualization setting. But I believe that's only visible in the editor, in the scene view. It's not something that's part of the script. So having done that, having assigned all the child objects button, we go back to our AI object and we insert the waypoint object that contains this waypoint circuit script in the circuit slot of the waypoint progress tracker. So back here with my AI, I've inserted this object, the waypoints object, in the circuit. I've got my target here. I've got my target here, and I also have my target here. My cube motor is following this target, and the waypoint progress tracker is moving that target, and it's traversing this particular waypoint circuit. So everything's set up now. So let me play this. And the tracker object is that little blue sphere out in front of my character. I have the gizmos turned on so that I can see the circuit. And you can see this character is following this little target around, and the target is moving ahead of it. Now, one thing that's really nice about this system, of course, is that if I slow my character down, the waypoint circuit accommodates that change in speed of my character. And so the waypoint circuit tracker is keeping track of my character's speed. This little green ball is apparently where I am on the circuit, and where I'm headed is that little yellow or that little blue ball. And there are various settings here that you can adjust for the waypoint circuit tracker. Things like the look ahead. Let me set this back up to 30 again. The look ahead for target. This is how far ahead of my AI the target is going to go. A weight for that look ahead for target weight, and also a look ahead for speed. So it can also anticipate how fast my character is going and where it's going to end up. And generally these defaults are okay, but sometimes you can tune things up if it's not behaving properly. We can progress smooth along the route, or we can go point to point. Point to point is going to go directly along the straight lines between the points. Of course, turning gradually because the character has to rotate using its own motor. And the proximity that I mentioned in the simple script is the point-to-point threshold. So here it has to get within 4 units of the waypoint, not the target. It's not the target's moving, but it has to get within 4 units of one of the waypoints in order for it to go on to the next waypoint. And so that's a simple little waypoint follower that uses the little cube motor, and it tracks around here. And of course, if I don't want to see that gizmo, I can go into the character's cube here and just simply turn off the renderer on that target. And I can also turn off gizmos so that I'm not seeing this track, and my little character is now moving around in the world following this little path that I've set up. So let me again stop sharing and entertain any questions. Where'd everybody go? We're down to 8 people. That's terrible, because this is good stuff. So feel sorry for people who came and left. Any questions? Somebody else just left or just came? All right, so that's all very cool. In standard assets, there's a car. Standard assets has under vehicles, car, it has as prefabs in addition to the car that we drive around, it also has a waypoint-based car. And so with no more fiddling than doing these waypoints and setting its target, where's its target? It has a waypoint target somewhere in here. I believe it's in the helper. There's the waypoint target. And I've got a waypoint circuit. It's actually the same waypoint circuit that I've used here. And in the car, I have to put the waypoint circuit in its waypoint progress tracker and its waypoint target in here. This is all set up in the prefab. And my car now drives around this little circuit, and it's following the gizmo path, and it's adjusting its speed and doing all the stuff it needs to do to circulate around that target. You notice the car actually puts on the brakes when it needs to slow down to make it around a particular curve. So that's all very, very cool. And one more quickly here. We had the dude, this little character that was a follower, and it had a target that it had to follow. So doing nothing more than putting a waypoint tracker in the dude and assigning and giving it a waypoint tracker object and assigning it to its target and putting its target in the waypoint progress tracker. I now have and this is using the run jump controller. So this little character is going to run around this circuit, and the animator is handling the animations and the root motion. So there's nothing more in here than just putting the target in its motor and having it go. And of course, I can have a little gang of followers who are all following the circuit. You remember that with the follower, it threw a little bit of random speed. So some of them are running faster than others. And so some of them are going to make it around the circuit faster than others. And it's all very, very cool. And this is waypoints. I'll show you these the next time. I'm going to stop sharing, entertain questions, and I'll show you some high-test examples of waypoint circuits in action, racing cars, flying airplanes. The airplanes do this too. The standard asset AI airplane also is a waypoint tool. So you can fly airplanes around from target to target. Very cool. You're happy with that, huh, Henry?
Sounds cool.
It is cool. It is very cool. Getting AIs to do things in our world is fun. And, so we can have our AIs that are set up to patrol. When a player comes inside some target, some trigger that's set is trigger, that is trigger can go out and change the AI from targeting the waypoint circuit to targeting the player. And it'll then come over and fight with the player. And when the player leaves that target sphere, the AI, the target will set the AI to go back and target the waypoint circuit, and it'll go back to patrolling with that mechanism system that we turned on and off lights. As simple as that. Pretty cool. No questions? No questions? I'm going to stop recording here.